Hello and welcome to this video on partial fractions. Now, remember those questions you used to have at GCSE using algebraic fractions, you know, timesing two together and then cancelling down? Well, it's kind of a similar process as you will find in partial fractions in Core 4. However, with partial fractions, you're starting at the end and effectively reverse engineering it. We're going to take the question x minus 1 over x plus 1, x plus 2. And we're going to split this into two fractions. We're going to split into a over x plus 1 plus b over x plus 2. Now, we're using a and b just to represent effectively integers, or not really integers, but just numbers that we don't know, and we're going to work them out over the course of this video. Now then, as you can guess, one of the ways we might do this is to cross-multiply the two fractions together. Correct. That's exactly what we're going to do. So x plus 2 a plus x plus 1 b equals x minus 1. Now, I haven't written the denominator over just because the denominator is the same on both and it just saves me a bit of time, and you probably won't need to in the real thing. Now, the way in which you can then go about solving this question is as follows. You can make, as you can notice, we've got x plus 2a and x plus 1b. So if we make x equal to minus 2, then minus 2 plus 2 is 0. So a is cancelled out, and what we end up with is just b on its own, and then from that we can obviously work out what b is. So in this case we have minus 2 plus 1, minus 1, so we have minus b equals minus 2 minus 1, minus 3. So minus b equals minus 3, b equals 3. And then we also have, then we can also do the opposite and make x equal to minus 1. So that will be minus 1 plus 2, so a equals, minus 1, minus 1, minus 1. Sorry, actually write this out. X equals minus 1. So what we have, minus 1 plus 2 is 1, so a equals minus 1, minus 1, minus 2. So the question you're going to be asking yourself is, well, is this right? And we're going to find out whether it is or not now. So we can write this as minus 2 over x plus 1 plus 3 lots of 3 over x plus 2. Now, that is a valid answer. You must write it so that you've got your constants actually, you know, in place of a and b, because just writing a and b is wrong. Now, here's the important bit. Is it right? Now, we can know this by simply just cross-multiplying again. So we can times them both together and we end up with minus 2 lots of x plus 2 plus 3 lots of x plus 1, which gives us minus 2x minus 4 plus 3x plus 3 equals x minus 1. Therefore, we know we are correct, as x minus 1 is the same as up here. So, now that we've done that, I'm just going to teach you one last thing on this video, and that is simply how to integrate a partial fraction. So say what they wanted us to do was integrate x minus 1 over x plus 1, x plus 2. And obviously you can't do that, but now we split it into partial fractions, we can. So what we will do is we will integrate minus 2 over x plus 1 plus 3 lots of x plus 2. Sorry, plus. Now then, do you remember back in Core 3 we had ln? Now ln, or ln, is quite a useful thing, I'm going to call it, in Core 4. So what we know is if we have 1 over x, it will integrate to be ln x. Same principle here. We can write this as minus 2 over the integral of 1 over x plus 1 plus the integral, the integral of 1 over x plus 2. Note we have taken those two constants outside the brackets because they're 3 times something. So what we can do is we can rewrite this as minus 2 ln x plus 1 plus 3 lots of ln x plus 2 plus the constant of integration plus c. Remember the plus c, you know, I'm sure if we all had a penny for every time we forgot plus c in questions, we'd be very rich, etc. So yeah, that's partial fractions, most of it in a nutshell. You can do some binomial stuff with it, but there is another video on binomial for you all to peruse. So quite simply, split it up into its two key components with one algebraic bracket on as a denominator, cross multiply them together, try and cancel one constant out by making it equal to 0, and then obviously rewrite with the correct value on top, and then integrating. Remember that you can use ln if it's 1 over something. Thank you for listening. I'll see you next time.